Hello and good afternoon. Welcome to Escape's quick free tutorials. I'm going to try and show you very quickly how to set up volume caustics. There are quite a few caveats in setting this up. If you get just so much as one thing wrong or you forget one thing, it just won't work. So please take notes and listen studiously in order that you make sure you tick all the right boxes and therefore get this wonderful effect. So very simply, let's start by creating a sphere. Let me turn off the interactive creation and let's create a sphere again, and let's just leave it at 1 unit. What I'm going to do is create a spotlight for this, so create light spotlight, and I'm just going to hit T, the special manipulator, so I can move the spotlight out, and I can hold down X and grid snap the interest to the centre of the sphere. I'm just going to raise my spotlight up so it's coming down at a funny angle. Now with the spotlight selected, if you go look through selected camera, you can see the spotlight and its area of interest still, the penumbra, this circle. So I'm just going to frame my nerve sphere so it's just slightly smaller than that circle. Now I always create a camera to render through, so let's create the camera and have a look through the render camera. So perspective camera 1. And what I'm going to do is just bring up a resolution gate for myself so I can see how this frames. Now I want the light, let's select the ball and hit F, so we frame on the ball. I want the light to come in pretty much sideways onto the ball, like so. I'm going to hit T, or rather W, and just make sure if I double click on the move tool here that we're in object space, which means I can just move the light backwards and forwards along its own axis. So let's look through selected again. And I'm just going to change the penumbra here, so it's just tight, oh, not the penumbra, rather the cone angle, so it's just tight around the sphere again. And these things always look good. Since we're accurately modelling physics light, it makes sense to use a proper decay rate. At the moment there's no decay, which means the light is at constant intensity all the way through space. That's not what happens in the real world. In the real world we have what's known as cubic decay, meaning the light falls off very quickly with distance. So I'm going to start off with an intensity of 500. Let's have a look through my camera and let's just check and see how this looks. So if I just render through the render view, let's make sure we're a mental ray renderer. Just do render camera 1, and I can see there how bright my light is. That might be a bit too bright, so let's try maybe 3 for now. Now I'm going to add some ray traced shadows for this light, so let me shut down all these tabs and open up the shadow tab and turn on ray trace shadows. Render again, there should be no difference. Now what I need to do is create a volume to see this in, and what I mean by volume is like smoke, for example. You're in a disco, they put the smoke machine in there. Now volume rendering is very processor intensive, so the way mental ray gets around it is you actually define the volume for which you're going to shade within, so it only actually renders within a certain fixed area, thus hopefully reducing all complicated calculations. So I look through perspective view, I can see my camera and my light. What I need to do is create a volume that encapsulates both objects. So I'm just going to create a cube, very simply. This is just a container, literally, for the volume. Let's go into wireframe. I just need to make sure it's only as big as it needs to be, so let's just scale it up ever so slightly in that axis, and it doesn't need to be so high in Y. And it certainly doesn't need to be that high wide in XZ either, the way I've built this. So there we go, that's kind of optimal for the volume. So I'm just going to rename this node. Instead of pCube1 in the transform node, I'm going to name this volume. And I'm going to use a predefined setup I have here of 3 panes with the top split. So let me just save my scene in case it crashes, because Maya is notoriously unreliable when it comes to crashing. Now I've got my volume cube here. What I'm going to do is just right click, oh no, in fact let's add a let's right click on it and just assign a Lambert, bog standard Lambert. Now with my Lambert I'm going to whack the transparency up so I can't see the cube, and I'm also going to create a layer from selected, make sure the volume is selected here, and do layer create from selected. This means I can toggle the visibility on. I want it to be on, otherwise it won't render. What I want to do is turn it into, click this button here twice so it's R. In other words, a reference object means I can't accidentally select it. So that's very useful. Now here's the volume shader node. So if I just expand that out, we can see it's got a shading group. I'm going to rename this Lambert volume shader. Now in Mental Ray we can override the Maya shaders in the shading group here. If I close down the shading group attributes, these are all the Maya shaders. In the Mental Ray section, if I close down contours, it says custom shaders here. This is where you can add all your custom Mental Ray shaders. Now if we're doing this, we need to suppress all my shaders, and what I want to do is I don't want to calculate the material or shadow properties, just the volume properties. So in order to do that, I need to first of all, in the Mental Ray section here, click on materials and use a material right at the bottom called transmat. Now with the transmat, I'm going to drag that into the material shader and the shadow shader of the Lambert's shading group here. And what this will do is actually put a null object in here for Mental Ray. Mental Ray just won't bother calculating material or shadow attributes. I do want it to calculate, on the other hand, volume and potentially photon volume attributes later on, but not photon either. Now I can't use the transmat in the photon shader, but if you look in volumetric materials, in photonic materials here, you'll notice we've got a transmat photon. That is to be added in the photon slot here too, which means these two will not be calculated either. Let me just tidy up the network a bit. Now what I need to do is add my two shaders now to shade the volume, and the one we use in Mental Ray is known as party volume or participating volume. They call it the participating media because it's basically like water with bits of detritus in, or it's air with dust in, that kind of thing. It scatters the light as it goes through the volume. So let's set that shader up. If we look here again in the Mental Ray section, under volumetric materials we have party volume, and also under the photon volumetric materials here we've got the party volume photon 2. Two shaders for the same job. Lovely. So if we drag the party volume into the volume shader and the party volume photon into the photon volume shader, this is correctly set up now. Now these two nodes, if you look at them, are pretty much the same. If you set one up, you have to set up the other one with exactly the same settings, otherwise the photons look different to the volume. So the way I can guarantee this, instead of having to change the values on both nodes, what I do is I tend to take the normal party volume and middle drag it into the party volume photon shader and choose other. This brings up the connection editor, so I can connect together all the common attributes like mode, scatter, extinction, R, G1, G2, non-uniform, height, minimum step length, maximum step length, light distance, min level, and no global illumination where direct. Do not connect up the lights attribute, that's just a light list. It uses Maya's light linking, so you don't need to worry about those. But now if you look at these nodes, the volume photon one here is all yellow, meaning it's directly connected to the party volume here. Now at the moment this scatter is our scatter colour, so if we're scattering any light it's going to come out black, in other words we won't see it. So I'm just going to give it a colour. So now I should definitely see some kind of scattering and it will come out this grey. And if I look at the photon volume shader, that too has picked up the settings because we've just made that constraint between the two nodes. So I only need to adjust one node now and all the settings will be updated on the second node. Now there's a few caveats here. So first of all, let's have a look. If we render, what do we get? Nothing. The reason why we get nothing is we need to actually tell Mental Ray to render a volume. And we go to the Features tab here. We just have to wait a minute for this to load up. And in the Features tab, we will notice down at the bottom there, we'll be able to turn on what's known as Auto Volume. That lets Mental Ray know that we want to start to render volumetric objects, and this is off by default because it's traditionally very ray processor intensive when it comes to ray tracing. And here we go, there's auto volume, so let's turn that on. And now if I render again, we can see we're getting the light through the volume, but we're getting no shadow from our sphere. Now in order to see the shadow from our sphere, we need to change again some more settings. So get your pen out to write these down please. In the spotlight we will notice that we are creating ray trace shadows. So how comes we don't see them? Well, we don't see them because we do not have enough sampling. Now the threshold for sampling is actually 4. We need 4 shadow rays and therefore a maximum limit of 4 as well. Otherwise that will just cap it to 1. And also in the render settings too, in our ray tracing section here, again we need to set the ray trace depth to 4 and the shadows to 4. Let me keep that image for reference. Now if I render again, you'll see we now have our shadow. If I set this to 3,